Welcome back to Only Space Mars Report podcast, where we break down the science shaping humanity's next giant leap. Today, we're diving into the region on Mars that researchers increasingly believe could host the first very large-scale human habitats, Arcadia Planitia.
This isn't sci-fi speculation. We're talking about fresh geomorphological studies, radar data, and even thermal economic modeling that specifically evaluates how to build big, as in multi-module, long-duration settlements right there on Arcadia's frozen plains.
Let's start with the big question. Why Arcadia? Recent research shows Arcadia Planitia checks almost every box for large human habitats. The terrain is incredibly flat, which is rare on Mars and ideal for landing heavy cargo and constructing large structures.
And the real star of the show? Near-surface ice. Multiple datasets, radar, thermal inertia, neutron and gamma ray readings confirm widespread accessible ice just below the surface. We're talking inches to maybe a foot or two down in some areas.
That's huge. Water is life support, fuel, radiation shielding, agriculture, and everything needed for in-situ resources. And having it right under your boots means you don't need to haul it from Earth.
Plus, the region's polygonal patterned ground, those honeycomb-like fractures, tell scientists that the ice is stable and long preserved, likely protected during Mars's high obliquity climate cycles.
Let's dig deeper into that ice. A 2023 geomorphological study looked at 3 candidate landing sites, EP1, EP8, and AP9, and found high-centered sublimation polygons everywhere.
Those polygons matter because their size and shape correlate with ice depth. Larger polygons, deeper ice. High-centered polygons, ice that's sublimating from the center outward. It's like nature's blueprint for where to build.
And shared radar data backs this up. Subsurface layers show strong signatures of buried ice, while neutron detectors suggest even larger reserves deeper down.
There's still debate over whether it's excess ice or poor ice, but either way, the consensus is clear. Arcadia has the most accessible, construction-friendly ice in Mars's mid-latitudes.
Now, let's talk scale. Not just small outposts, large habitats. A 2023 thermoeconomic study from Imperial College London created a full analysis system called ARHS to evaluate big, long-duration habitat designs specifically for Arcadia Planitia.
This model looks at everything: life support loops, food and water cycles, waste recycling, energy generation, heating and radiation protection, human physical and psychological limits.
And the findings are wild. Arcadia's flat terrain and shallow ice dramatically reduce habitat mass, energy requirements, and construction complexity. That means you can scale up. Clusters of modules, large greenhouses, industrial zones.
Think of it like a Martian campus: surface solar farms, pressurized tunnels, subsurface living quarters carved into ice-reinforced regolith. Even kilometer-scale structures become feasible when the terrain cooperates.
3 major habitat concepts are emerging from the latest research. 1. Subsurface ice vault megastructures. Using thick ice layers as structural mass and radiation shielding. Ice can be carved or melted into domes, then reinforced with regolith. This is the safest long-term option.
2. Surface superstructures on flat plains. Arcadia's smooth terrain allows large inflatable habitats, 3D printed regolith buildings, massive solar arrays, and landing pads for heavy vehicles.
3. Hybrid underground and surface cities. A mix of buried living spaces and surface industrial zones. Pressurized tunnels connect everything. This model mirrors Antarctic research stations, but scaled up.
And all of these concepts rely on Arcadia's unique combination of flat land and shallow ice. That's why researchers keep circling back to this region as the most viable place for a true Martian settlement.
So when people ask, where will the first real Martian city be built, the science is pointing more and more towards Arcadia Planitia.
It has the resources, the terrain, the climate history, and now the engineering models to support very large, long-duration habitats, not just survival modules, actual communities.
And as research accelerates, Arcadia is becoming less of a question mark and more of a blueprint.
Thanks for listening to Only Space Mars Report podcast. If you want us to break down a 1 million person Arcadia habitat, a cinematic version of this episode, or a business strategy angle on Martian infrastructure, just say the word.